Okay, hello everybody, Polymer Bob here. Today we're going to take a look at a mathematical problem that first appeared about 2002 in a mathematical tournament between MIT and Harvard. Now, about 3.5 months ago, this problem was taken up by an excellent mathematical education YouTube channel known as blackpenredpen. I believe their host is a mathematics professor. Now, the original 2002 solution entailed infinite sums and some sophisticated integration. The professor on blackpenredpen was able to solve it using somewhat simpler calculus, like U substitution, I believe. What we're going to do is we have a two-step goal here. We're going to solve this problem using algebra and basic calculus, okay? And we're going to identify the function. Now, the function was not identified either in 2002 or on blackpenredpen, but to be fair, identifying the function was not a requirement of the problem. Now, when I say we're going to solve using basic calculus, does anybody remember that? Okay, that is a basic rule of integration. You probably learned that like around second or third week into calculus. Okay, I mean that is simple and basic. Like this right here is all the calculus we're going to need. We don't need any more than that. Now this is not going to be a short video. Okay, I don't want to make it seem like it's going to be like a quick 2 or 3 minute video. There's quite a bit of algebra that goes into the solution. So we have a little bit of work to do to get to the solution, but we're gonna get there. All right, let's go ahead. Let's get started. Now, let's go ahead. We're gonna start work on the function here. Let's say x equals 0. Set it to 0. Now let's go ahead and put this x equals 0 into our function. Now, f of 2x is f of 2 times 0. That's f of 0. Now, 3 times f of 0, right there, 3f of 0. Okay, well this is an interesting result. Now let's go ahead and do a little subtraction. Minus f of 0, minus f of 0, and we get 0 equals 2 f of 0. Okay, that is pretty definitive. We now know f of 0 is 0. Okay, if f of 0 is 0, then what could the function be? Well, let's take a couple of guesses. First, let's guess that the function is linear. We don't know, but now let's take a guess. So, if the function's linear, that would mean that f of x is kx. Okay, so let's put that in here. We have 2x. We have k 2x equals here 3kx. Okay, so what this is basically saying is that 2kx equals 3kx. I'm afraid not. That's not true for all x, so we know we do not have a linear function. Okay, let's go over here and let's guess that it's an exponential. Okay, if it is an exponential, then we are of the form b times a to the x. Let's put that over here. We have b times, x to the a. So we have b times 2x to the a equals here 3b x to the a. Okay, now right away we don't see anything that would eliminate this from contention. What we can do is we can cross out the b's, divide both sides by b. Now, that doesn't mean there's no b, it just means that the b can be anything. We're going to find the identity of b later. So this leaves us with 2x to the a equals 3x to the a. Okay, now let's go ahead and let's take logarithms of both sides. So we have the natural logarithm of 2x to the a, make it a little bigger, is logarithm of 3x to the a. Okay, now we're going to break this up, and we have to be careful. It's easy to make a mistake here. So what we're going to do is we're going to say that a times the natural log of 2x equals log of 3 plus the log of x to the a. Okay, now we can break this up a little more. A times log of 2 plus log of x equals log of 3, and we can break this up, a log x. Okay, now let's distribute our a's here. We have a log of 2 plus a log of x equals log of 3 plus a log of x. All right, now notice we have an a log x here and an a log x here. Let's subtract that from both sides. That gives us a log of 2 equals log of 3. A equals log of 3 over log of 2. Okay, we've now found a. Here we have fx equals bx to the a. We still don't know b, but we've identified a. This a here is a natural log of 3 divided by the natural log of 2. Okay, we're a little bit closer. Okay. Shuffling through a lot of papers here. All right, now, see where that leaves us. Let's come up here. We now know that, based on the clue that they give us, the integral of f of x. Okay, what is f of x? Well, there's a b that we don't know. X times log of 3 over log of 2 dx equals 1. And this is from 0 to 1. All right, now, this log of 3 over log of 2, we're just going to call that a. So what that means is the integral of this would then equal, so the integral of 0 to 1 of b x to the a dx equals, all right, b a plus 1, right? Add 1 to the exponent there, and that's x a plus 1, and then we're going to go from 0 to 1. Now, when x is 0, all this becomes 0, so we really don't have to mess with that. We just have to worry about the 1. So what this tells us is that b over a plus 1, 1 to the a plus 1 equals 1. Now, 1 to anything, you know that's 1. So we don't have to worry about that. So b over a plus 1 equals 1. That tells us that b equals a plus 1. Now, what is a? A is log 3 over log 2, so we know that b equals log of 3 over log of 2 plus 1. That's a plus 1. All right, we have now definitively identified the function. F of x definitively is b. Log of 3 over log of 2 plus 1 times x log of 3 log of 2. Okay, that is the identity of our function f of x. Now we're going to take this function and we're going to use it over here to determine the value of this integral. All right, so here we go. There we are. Now, what we'll do is, just for the purposes of easy writing, we're going to call log 3 over log 2 a, and we'll call this constant here a plus 1. You'll see why in just a minute. So, f of x for our purposes is a plus 1 x to the a. That's what we're going to call it. Now we want the integral of this function, a plus 1 x to the a dx, as measured from 1 to 2. And that's what we're going to find out. Okay, now, what do? Well, the way you start is you add 1 to the exponent. That becomes a plus 1. So you have your constant here is a plus 1. Divide by your exponent plus 1. A plus 1, then add 1 to the exponent, a plus 1, and we're going to measure this from 1 to 2. All right, well, one thing's easy, a plus 1 over a plus 1, you can forget about that. Now we just need to plug the x to the a plus 1 into 2 and 1. So we'll write it out in full. We have x, okay, a plus 1. So that's log of 3 over log of 2 plus 1, okay, as measured from 1 to 2. All right, let's put the 2 in there. We have 2 to the log of 3 over the log of 2 plus 1, and from that we will subtract 1. Log of 3, log of 2, plus 1. Now, this one here is easy, okay? This right here is 1 raised to a power, so you know that's just 1. Can't do much with that. Now here, we see we have 2 raised to a power plus 1. What we can do is we can break this up by the laws of exponents. What we have here then is 2 log of 3 log of 2, and multiplied by 2, and then we're going to subtract 1. Now, what is 2 raised to the power log of 3 over log of 2? Well, I happen to have a handy-dandy little cheat sheet here that'll help us. All right. So 2 to the log of some number divided by the log of 2 is that number. So over here, 2 raised to the log of 3 divided by the log of 2. Well, that's just 3. You multiply that by 2, and then subtract 1. Okay, you have 3 times 2 is 6, minus 1 is 5, and that is the answer. So we have actually met both of our requirements. We've determined the identity of the function f of x, and we found the answer to the integral f of x 1 to 2 dx. So I think that's about all that I have. Thank you very much. It's been a pleasure, and I will see you next time. Take care.